Welcome to the session on Scala tricks. My name is Venkat Subramaniam. We're going to talk just a little bit about Scala, and then I'll go into quite a few examples to show some of the benefits this language has to offer, things that we can do in Scala. Relatively speaking, compared to what we do in Java, how we could make use of it. Best time to ask a question or make a comment is when you have it, so please don't wait till the end. Just about any time is a great time for questions, comments, just about anything you want to share, so don't hesitate at all. Definitely love to, you participating in it. So let's talk about Scala here. What's Scala and why should we use it? So Scala is a hybrid functional, fully object-oriented language on the JVM. It is a statically typed language. It's more statically typed than Java. I would say calling it Scala is statically typed like Java is an insult. You should actually think about static typing where there's quite a bit of type inference that's provided in Scala as well. And I did mention that Scala is fully object-oriented. What does that mean? You could do methods on primitive types as much as you want to. And the reason for that is in Scala, everything is an object. It's fully object-oriented. Now, of course, you may say, wait a second, if that's true, are we going to lose on performance? No, not really, because Scala is smart enough to realize when we treat a primitive as a primitive versus when we treat primitive as an object, and is smart enough to generate the appropriate bytecode under the covers for us. It is a functional language, but it's a hybrid functional language. And the reason for being hybrid functional is you can write functional style of coding with higher order methods like we normally do. But we can also write imperative code like we do in Java in a traditional style as well. So it gives us the flexibility to do this as we please. And you can use Scala anywhere you use Java, you can use it. And generally speaking, you're looking at about 40 to 60% less code in Java than you would need in Scala for writing code. The code I'm going to write here, you can download it on my website. The link is given on line number 5 right there. I'll leave this up here also if I remember towards the very end, or just remind me. So we're going to talk a little bit about Scala here, but one of the interesting things about Scala is that you would be able to make use of Scala efficiency. It compiles down to bytecode. You can intermix Java with Scala, Scala with Java. But what's also interesting is that Scala is extremely concise and it's also very expressive. It's a fun language to use, but it also takes a bit of an effort and there's a bit of a learning curve, but what doesn't? Let's look at some examples of what we're going to do here. What you're going to learn in this presentation is, rather than going through a language syntax or step by step what you can do with it, I'm going to pull some examples and show how you would build that in Scala. And as I come up with the examples, I'll talk a little bit about how that would be in Java, for example, and then we'll take a look at how we would build that in Scala. So let's get started. The first thing I want to talk about is reading a file. Now, everybody here who has written code in Java, remember how painful it is to read a file. I can see already a few people smiling already, right? And if you want to read a file, what do? You have to start saying new file reader, but that's not the real problem. When you get the content out, you got to start looping through and extract the content out. Well, that's not as if already a problem. We have to put exception handling code around it. All the try and catch blocks we have to write, remember that? And that kind of gets a little messy. So a simple code to read a file and get the content out can easily become 30 lines or so, right? And that's pretty tedious for us to work with. Now, how do we go about to read a file in Scala? Let's take a look at an example. Maybe I just want to read this file itself. So I'm going to first of all import scala.io package here. And the underscore in Scala simply, by the way, underscore in Scala stands for different things based on the context in which we are using it. But in this context, we are saying just bring everything from that particular package. It's kind of like the star in this particular context that we use in Java. So I'm going to simply say console is an object that we can use to, it's kind of like the system object, and I want to print out stuff from it. And what do I want to print out in here? I'm going to go to the source object and I'm going to ask him to read from file. And the file I'm interested is sample.scala file that I have given to him. And once he gets the content, I'm going to ask him to combine that into a string. Make string joins the content together as a concatenated string, if you will. So you can see that when I'm running this code, it just pulled in the content of the file itself and displayed it for us. And that was kind of fairly easy to do, as you can see. If I lower the font here, you can see the actual code I wrote here. And that's the line of code I wrote here, as you can see. Very simple. So all that I did was I said print out, and we could store this as a content if you want to do. Say here, for example, I will say stuff equals, and this is basically source.fromFile, and I gave the file name to him, and then asked him to concatenate that into a string using the make string function. And then once we are done with it, we could just print it by asking him to print the stuff, and we can see the code printing the content itself. Now we can take a look at that right here. So very simple, a higher level of abstraction, as you can see here. A couple of things we didn't have to do. What about exceptions? Now think about exceptions for a minute. What does Java say? Java says there are runtime exceptions and there are checked exceptions, right? Now, it seemed like a great idea when Java was introduced, but over the years, we have realized that checked exceptions burden us. Now, what do we do in Java for a minute? Imagine for a minute something as trivial as thread.sleep, for example, right? You say thread.sleep. Can you call thread.sleep just like that? And Java says, no, you got to handle the exception, isn't it? Then you put a try block around it. I mean, I have spent sleepless nights calling thread.sleep and wondering what I'll do with that exception, right? How frustrating that is. And then you say catch exception, and what do programmers do? You know, Java programmers are very smart, right? You can't force a programmer to do something. And so when you say exception, you have to handle exceptions, and the Java compiler says, you will handle the exception. And the programmer says, let me show you who's in power here, and puts an empty catch block around it, right? There is no way to win this game, right? So Scala says, enough of that. Let's give responsibility to the programmer. We'll treat them with respect. Let them handle exceptions they care about. Otherwise, they'll deal with it in any other way that they have to deal with, right? So we don't have to go through all of that. So you don't have checked exceptions in this. So it turns out checked exception was not a concept on the JVM. It is something imposed by the Java compiler, and the JVM cares less, actually. So the Scala compiler doesn't have checked exceptions. That minimizes quite a bit of code we have to write as well. So that helps quite a bit. Did you also notice one more thing I did here? I just started writing the code to read the file. And this is one of the beautiful things that I really like about Scala, is that there is no ceremony to deal with. Now, think about this for a minute. In Scala, you could write as little code as you want to, or you can write as much code as you want to. You know, sometimes people say, what does the word Scala mean? Well, the word Scala actually is really meaning, it's a scalable language. And you say, what does scalability mean in this context? Well, the word scalability is loaded, isn't it? Means different things to different people. Well, in one context, the word scalability means you can write a 2-line code in this language if you want to, or a 20 million lines of code if you want to, right? It's in scale up and down. But did you notice one thing already? Notice this is a lack of ceremony, if you will. Now, what is ceremony? Ceremony is where you have to do stuff you don't want to do before you can get to do what you really want to do. And anybody here who loves ceremonies? No, he was not raising the hand, right? No, absolutely not. He was just coughing. That's something really damns us. My good friend Stuart Halloway has a blog entry. He talks about essence versus ceremony. And a lot of times when we have ceremonies, it becomes a real big problem. Let's look at a ceremony that we have eliminated here. Anybody who had to teach Java to other people, have you done that before? It's okay among friends. You can raise the hand. Yeah, absolutely, right? And how do you feel about it? It was kind of really challenging, wasn't it? You had a captive audience in front of you and you said, I will teach you Java. And the person said, is Java really hard to learn? You said, no, honey, it's very easy to learn. Because all the books say Java is simple. It's got to be simple, right? It's like, okay, teach me something simple. How about a hello world? And you said, great idea. So what did you do first? You said public. And the hands goes up. What does public mean? Well, you don't need to know that right now. Okay, all right, fine. And then you said class. Immediately the hand goes up. What does class mean? you don't need to know that right now also. And the person, good student, notes down, no need to know what public is right now. No need to know what class is right now. And then the person said, hello world. And you type hello world, there's a glimmer of hope. It's like, yes. And then you put a curly and that came crashing down. They're like, what now? Then you said public. And the person immediately looks up the notes. Okay, I don't need to know what that is right now. Then you said static and that's it. You drove this person crazy, right? Is that something I don't need to know right now either, right? And they don't even know the main coming next. You can imagine, what is that? That is ceremony, right? You say, wait a second, but Venkat, you cannot run a piece of code on the JVM unless there is a static void main somewhere. That's correct. And Scala says, that's the JVM's problem, not your problem. So Scala says, you don't have to do anything you don't care to do. If you want to put hello world, get down to hello world, right? So you just say hello world, and what does Scala do? Scala says, I will take this piece of code, write a class for you, write a public void main function for you, stick that code inside, compile it down to the bytecode, and I will run it so you don't have to waste your effort. So that is essence versus ceremony. You don't have to do anything that you don't care to do, so you can focus on doing what you really like to do and get your work done. So that is again something that Scala has really built in, and that's why we were able to simply say, file, open the file using source.from file and just do the work rather than dancing around giving classes in main, which doesn't give us any value at all. So that is an example of reading files and how we can get the content out. Now, I want to be able to create objects. Obviously, we want to create objects and use them. How do I create objects really? Now, this is one of my favorite features in Scala, and this is basically a concept of tuples. Now, how many times have you been writing code in Java and you wanted to return a pair of values from the function? And you wanted to return two things, and Java says you can return only one thing. And you sit there and scratch your head, how do I return two things when it can only return one? And I'm sure you have tried to return arrays or maps and stuff like that, and nothing really felt right when you did that, right? Well, here is Scala. I'm going to say, for example, create. And I want to create an object, let's say create agent, right? So because Scala is just like this agent, it's really powerful. And what do I want to do here? In this method, I simply want to return. And what do I want to return? I want to return the agent's name here, right? So I'm saying James Bond, right? Absolutely. So that's how simple it is. No ceremonies again. But what did we do on line number 2? On line number 2, we created what is called a tuple. Now, a tuple basically is one of the coolest objects in my opinion because it is very lightweight. We were able to create it very easily, and it is immutable. So you don't have to worry about somebody messing with it. And you can just create this and throw it across the fence. What do I mean throw it across the fence? What I mean by that is tuples are really nice objects when we want to call across actors. For example, if you want to use concurrent programming, you can send them as messages across. They are very nice candidates, if you will. So I'm going to say over here agent equals, and in this case I'm going to say create agent. So got the agent back from the call, and I can now print out the agent's name. For example, I can say agent dot underscore 1 plus, and then I could say plus agent dot underscore 2 to get the last name in this particular case. So I'm able to go call these methods on this object and get the stuff I need from this object, and this is basically a tuple that I'm dealing with. Now, you may look at this and say, gosh, that underscore 1 looks a little odd. Well, I have to tell you something. Yes, it does look odd. Okay, so, there's a very easy way to deal with it. My recommendation is get over it, right? So, I mean, that's the way it is. But here's the beauty of it, right? Look at the positive aspect of it. You can get a compile time error if you go out of index. Now, think about that for a minute, right? If you're using a collection like a list, and you say, get me the 7th element, what would the compiler do? The compiler would say, good luck, right? And create the binary for you. At runtime, it blows up with index out of exceptions because it doesn't have as many elements. But the beauty here is, if I go to the agent and say, give me the 3rd element, notice the code is not running at this point. It gives you a compile error saying, I don't have a clue what underscore 3 is because there is no such element. So this is a compile time error. Why? Because when we created this tuple, it knows that this tuple only contains 2 values and not 3 values. On the other hand, if I do modify this and maybe specify a 007 here, I'm sure I can now say agent and get the index number 3 right now, but Scala is smart enough to figure that out. So it gives a compile time error when you step out of the index at this point. So we took what could be otherwise a runtime error and made it a compile time error, and we can do some kind of checking at the compile time as well. So that is an example of how we can use tuples, and tuples really are very lightweight and they're immutable. That's the part I really like about it. You cannot change it once you create it. All right, you say that's kind of nice, but I still want to be able to call this with meaningful names, like a first name or last name. How do I do that? Now, typically when you have to do that, what do you have to do? You got to create a class, and you got to create an object of the class, right? And that kind of becomes a burden for us to create classes and objects. Let's talk about creating classes first, but then we will see how even more simple this becomes by removing that burden, and we have what are called anonymous classes in Scala. We can use them also. But before we get to anonymous classes, let's talk about classes itself. Now, we all have created classes in Java, right? How many of you are excited about creating classes in Java? Well, Martin is here. I'm so, glad to see you here. All right. So, well, I got to lower my praises for Scala now, knowing that he is here in this room. Did not notice. So one of the things I really like about Scala is that it really removes the ceremony I mentioned. Talk about Java for a minute, right? Well, how do you write a class in Java? You say public, and then you say class car. And then what do you say? You say, well, private int miles, and then you say private int year, and then you say public int get year to get the year value, and then say return year, right? And then you say, oh, I forgot to put final after all. Look at all the ceremony that goes into it, right? Then you have to write public void set miles to set the miles, and you know where this is going, right? And that's a lot of work, isn't it? I know what you're thinking. You're thinking, no, Venkat, that's really unfair. I never do that. I only type this word miles, and then I gently right-click on it. And before I could blink, the IDE vomits the rest of Java code for me, right? So what you're telling me is not only do you need a language which is complex, but it has to ship with an IDE that constantly vomits, right? And who is going to be dealing with that vomit every day? No, we don't have to do that. So one of the things that Scala does is, if that is what we normally do, that should be part of the language, right? It's a sensible way of writing code. So basically you say class car. You say, wait a second, how many times do you make a class non-public? Well, very rarely. Well, then it's public. Don't say otherwise, right? So if you want it to be something other than public, say so. Otherwise, don't bother saying it. So you say class car, and then you basically say, in this case, I want the year, of course, but I want the year to be a final. So this is one of the things I really like about Scala is you have to make a clear decision whether you want something to be final or not. Now, in Java, that kind of comes after the fact, like you saw me do, right? I wrote the year and said, oh, darn it, I forgot to make it final. When I was writing the concurrency book, I recommended that when you're coding in Java, make all variables as much final as possible. Easy recommendation to say, isn't it? But before the book went to the printers, one afternoon, I spent the entire afternoon combing through the Java code, looking for places where I forgot to put final. That was the lowest point of writing that book, right? Finding where I forgot to put final. And when the book came out, one guy tweeted saying, oh my gosh, I found out that Venkat uses the word final 350 times in his book. And I tweeted back saying, but you still don't know where I still missed it, right? And that is frustrating. But we don't have to go through that. You want to make a clear decision, and Scala says, you must decide right now whether you want this to be a val or a var. But even better, if you decide to make it a val, that's good. But if you make it a var, we can easily identify it. Why? Because we can do a grep quickly and say, grep minus r, var star. It will tell me every place you're using a var in your code. How do you grep for forgetting final? That's one heck of a regular expression to write, isn't it? So it makes it a lot easier to find stuff also in this case. And then, of course, I can say miles is a variable. and then I can say miles colon and then int, and it becomes really easy to provide it. You say, wait a second, what about the getter for the year? Well, that's done. What about the getter and setter for miles? That's done. Hey, what about the constructor for the car? That's done as well. I know what you're thinking. What do I do with my free time? Go home, right? You don't have to be sitting and writing stupid code. The language takes care of it for you, right? And that is the beauty of it. So in a sense, in Scala, you don't write a class. In Scala, what you do is you write a nice constructor. So in this case, if you notice over here, I said here for a minute, and I'm going to just call this constructor right now. And if I say new car, let's say 2012 and 0 miles, you can see that the code is going to run through, and it's going to call this particular year that I'm going to use here and execute it at this point. So the point really is that you are really writing a healthy constructor, a primary constructor, and that takes care of the rest of the things. In a sense, I view this as in JavaScript, you don't create classes, you create a constructor function, and Scala kind of falls on that line saying, create a constructor, it kind of becomes like a factory object method, and then you can rely upon it. So that becomes really healthy to use it. So that is an example of how we could use this. But you say, all right, this is already great, but I really want to return back this particular lightweight object, but I want to be able to call first name and last name on it. Does it mean I have to create a class called person and then put a first name in it and last name in it? And the answer is no, we don't have to do that. It's even more simpler than that. So I can say create agent one more time. And if you recollect, we had this a minute ago where we said here's James and we had Bond over here. And I created an agent over here. So I said agent equals create agent. And of course, I want to print out, in this case, the values of this agent itself. So in this case, I'm going to say agent dot, let's say _1. And then, of course, we said here's the agents _2, and we printed it out. Now, what I want to really do is to minimize that effort, right? So I can simply say, I don't really have a use for this class outside of this context. So rather than wasting time creating classes, we'll simply create a new object on the fly. This becomes an anonymous instance we can create. And I say simply first name equals, and I can put a value into this. And of course, I can say last name equals, and then put a value into it. And now we have created an anonymous instance on the fly to send it across. So what can I do here? I can simply say first name, and then of course, I wanted to get the other value. In this case, I can simply say last name and print the value out. So this is an anonymous instance. So not only is it easier to create classes, Scala makes it very optional even to create classes, and yet you can have this compile time verification very nicely. So we looked at a couple of interesting features now. Now here's a feature that is pretty interesting, but also a little bit scary sometimes for people to use. And one of the things about this is you can provide a bit of a fluent interface by using some of these features. For example, let's say I want to say something like this, 2.days.ago. That would be so cool to do, isn't it? But it doesn't work, unfortunately. Why? Because it says, I don't have a clue what days means. But remember, we already talked about this, right? Scala is fully object-oriented, which means you can call methods on any object, and primitives are treated as objects in a very sensible way. And so there's no overhead to treating them as objects, in the context of treating them as objects. But why not enjoy the fluency? Well, we're going to make that code work, but not yet. I will eventually make that code work, but let's see how simple it is to make something like that work very nicely. So let's take an example here. I want to simply say a class called, let's call it as int util, for lack of better words. And this is going to take a number as a parameter, which is an integer. So I'm going to pass this as a constructor. So we learned how to write classes a few minutes ago. I'm creating this class here called int util. And what is this going to do? It's going to take a number as a parameter. So how would I call this? And I'm going to simply call this as new int util and send the 2 to it. Not quite the syntax we were hoping for in line number 7, but we will see how we can refactor to that in a few minutes. So this really creates an instance for us. All right, it did that. Now I define a method called days over here. And this days method is going to simply return the current object. So now I can go back and say dot this, and in this particular example, that's adequate for what we want to do, and I'm going to just call the days over here. Scala makes it optional to put parentheses in different places, so we are leveraging that feature. Then I write a method called ago, and what I'm going to do in this method is simply create a calendar object. Let's say 2 equals, again this is purely an implementation, you can use whatever implementation you want to use, and I'm going to say calendar over here, and let's say get instance. So I create an instance, and I'm going to return from here today dot, let's say get time on this. Now, of course, I want to bring in the calendar, so I'm going to say import java.util over here. So we are intermixing that right here, nothing wrong with that. And now I can simply say return the date, but in this context, I want to say today.add, and I want to add a calendar.days of month, and I want to go past, so I'm going to say minus number, and I've stepped back in time in the calendar object itself. So if I go back and try this out now, calendar dot is a day of month, right? So I'm just stepping back in time. How does this work? So I'm going to call the dot ago over here, and that tells us it's 2 days ago. Hey, that's cool and all that, but that syntax kind of looks a little ugly. I really wanted to get to that syntax. How do I do that? So here comes an interesting way to deal with it. So what I could do is I can define a function, and the function I'm going to define in this case is, let's call it as int2 int util, right? So you can call it whatever you want to call it. There's, whatever logical name you use, and this is going to be a number I'm going to pass in, and all that this is going to return is a new, and I'm going to return an int util with that number you gave me, right? So just a small function I'm going to use. So what am I going to do? How do I use that now? So what I'll do here is I will simply say, in this case, int to an int util, pass the 2 to it, and then call that method in there, and that seems to be doing the work. And you say, yeah, but that still is a noise. I want to get rid of that noise. What can I do? And here comes a feature that I believe borderlines between extremely cool and extremely scary. And the reason why it borderline that is, it is a very convenient feature, but this also kind of may introduce a little bit of a magic if you're not kind of watchful where the code is coming from. So you can simply say, in this case, you can say implicit. So this is a hint to the Scala compiler to say, hey, whenever you see a value being used, like a 2, for example, why don't you go ahead and look for a case where this could be promoted to an object, which in turn can support or satisfy this following property or method for me. And of course, Scala will go through and check for these implicits. If there's a collision of ambiguity, it will report it for you and say, don't do this. So that's not too bad. But you kind of have to know where this magic is being pulled in from. Especially if this is being pulled in from an import that you have, it may appear a little surprising to you where this is coming from. But this also is a great feature for improving job security as well, right? So you can definitely use that. So that is basically an implicit import, and you can use that very nicely. So we looked at some of these interesting features to use. Now the next feature I'm going to show you here is one of my favorites. Now imagine for a minute that you want to use a function to do some regular operation. You could write an iteration, right? So for example, I could write a factorial method, and in the factorial method I could say number is going to be an integer, and I want to return a big int, for example, and I could say in the big int, I could just loop through and implement this and say return the factorial of that number. But looping through would introduce probably a mutable variable, or you got to use other constructs, and eventually you say recursions would be really cool, right? How many of you love recursions? Of course, most of us love recursion because that helped impress people in school, right? They wanted to hang out with you because you could solve problem using solution to sub-problems. How cool that is, right? So recursions are awesome. The day I learned about recursion, I ran out in the street and I celebrated. This is awesome, right? How cool that is to use recursion. But unfortunately, recursions are, nice, but the next morning I was not that happy. What's wrong with recursions? Stack Overflow, that's right. So for example, I could say here, if n is equal to, let's say, 1, what do I want to do? Just return n, else return n times factorial of, let's say, n times n minus 1. right? We could have a big integer being returned for us. We could say big int on this one and return it, right? So this could be just a 1 in this case. So let's go ahead and try this. I say factorial and say this is going to be, for example, let's say 5, right? So that should be very easy to run through. But what if I say 5,000? Okay, that kind of worked as well. What about 10,000, right? You're kind of pushing it a little bit, and then it blows up with a Stack Overflow exception. How sad that is, right? Something as powerful as recursion, just it's within reach, but you cannot use it, right? So you say, what can I do? Well, here comes an interesting thing. There's a fantastic book out there called SICP, which stands for Structure and Interpretation of Computer Programs. And SICP talks about how you can, well, remember, first of all, anytime you compile your code, there's a transformation happening, right? The source code you write in Java is not the source code that gets compiled into bytecode. The JIT compiler takes a stab at it, so a lot of optimization happens already. SICP talks about a difference between a procedure versus a process. And a procedure is the code we write, and the process is the code that runs, right? Code that runs. And so the essence really is that you can write an iterative procedure and it runs as an iterative process. There's no surprise there, right? You write an iteration, runs as an iteration. You can write a recursive procedure, and like we just did, it runs as a recursive process and blows up when the stack is too large. But where really the fun is we write it as a recursive procedure, and it runs as an iterative process. Then you have the best of both worlds, because it looks at the code and says, gosh, this is so easy, I could optimize this into a real iteration under the covers, and you will never blow up your stack. So let's look at an example of how this would work. Now, what I'm going to do is, to do this, we need TCO, or tail call optimization. So notice what I'm going to do at this point. I take this factorial, and I'm going to say, let's say f is the factorial I'm going to bring in here. So in this case, f is going to be a big int, and then I'm going to say n is the value that I want to bring in here. So we start with that. So if n is 1, I want to return big int of 1. But what if I don't have a value of 1? Then I say return a factorial of f times n comma n minus 1. Notice the last call we make in here is the tail call itself, meaning the call to itself. A minute ago, the last thing we did was a multiply. So we had to hold the stack and say, I got to multiply, but I need the result from the previous level of the stack. Now we are saying, we'll do the multiply ahead of time, push that on the parameter list, and call the method itself. And the Scala compiler looks at this and says, hey, look at this. It's a tail call position. I can optimize this. So rather than calling the method, I can turn this into a while loop and say, as long as you're calling the method, keep calling it with the parameters. And the minute you're not calling this anymore and returning a result, return that result back to the caller. This is purely a compile time optimization that happens at this level. So I can go back and make sure I send a 1 and a 5 to this function. And you can see in this particular case, well, the first one is the factorial. Let me make sure I did this right. So say that again for me.
You got to return f there.
Oh, of course. So in this case, return f. Thank you for fixing that. So right there, we are returning the value itself. So that seems to work. But what if I try at 10,000? Remember, that blew up the stack the last time. And I run this now, and that seems to work fine. Don't memorize that result. You don't need to know that. So that worked really well, isn't it? You say, wait a second, but this kind of cool, but I'm not too happy with this. Because I have a colleague who has this absolute need to mess up things. And he wants to send a -1. What's going to happen? You got to explain, no, don't send a -1. You could use a default parameter if you want to, right? But the beauty of this is you don't have to go to that length. In Scala, for example, you can just go back to this and say, I want to define a factorial method which takes a number as a parameter. And what this is going to do is it is going to encapsulate, this is a functional style, remember? So we have a function within a function, so you don't have to run to a class to encapsulate. How cool is that, right? So put the function within the function. You cannot reach into this function from the outside. But then you can just call into this function right here and send the number that you want to send and ask him to produce the result for you. So as a result, we don't have to go through the trouble of class level encapsulation, but we used a function level encapsulation because it's after all a functional style language, so which means you can send function to functions, but you can create functions within functions and return function from functions as well, and you're able to do this. You say, all right, this is kind of cool so far, but what if I make a mistake and this is no longer a tail call? Is there a way to fix it? And yes, absolutely. You can say scala.annotation. And you can say tailrec over here, and Scala compiler now keeps an eye on you. So if you were to make a change to the code later on, and if it's no longer tail recursive, the Scala compiler will immediately ask you, what are you trying to smoke? This is not a tail call recursion anymore, right? So it gives you an alert of that very nicely. Now, how is this really working? This entire thing works based on the compile time optimization. Now, at this point, usually somebody gets very curious in the audience and they raise their hand and say, this is so awesome, can I do that in Java? And I got good news for you. Absolutely, you can do this in Java. Write the code in Scala and call it from Java, and you can definitely do that, right? So absolutely. Because you say, well, but when will Java have this? You know, it'll be really cool to have tail call optimization at the bytecode level, right? But the good news is tail call optimization will be available in Java between Java 9 and Java 23. But before that, right, we can definitely use it here in the compiler by using it in the Java compiler, the Scala compiler. Absolutely, we can make use of it. So again, this is a compile time optimization which we can benefit very clearly. Okay, great. Now, we looked at a way to manage the methods with tail call. We looked at ways to create objects, create lightweight objects. We can read files very easily. Is there more things we can do? And absolutely, there are some other fun things we can do. Let's talk about XML for a minute. I want to create an XML. So I'm going to say, let's say XML equals, and I'm going to say greet, and let's say hello/greet, right? So right there is XML, and I want to print this XML, so let's go ahead and print it, right? So that looks familiar, isn't it? What do you think of that XML? You said, that's no XML, right? And we have been cheating XML all these years. We keep putting it into a string and deal with it. I mean, honestly, how would you feel if you put in a string all the time, right? Then we complain that XMLs misbehave. Well, wouldn't you misbehave if you're in a string all the time? So Scala says, XML needs the respect it deserves. So XML is a first-class citizen. We dropped an XML right there, and XML can be handled just like a value can be handled, right? So you can create, for example, some value equals 25. Similarly, you can put a well-formed XML, and you can use that as well. But the beauty of this is you can go a step further from this. Not only can you create XML in the code where it makes sense, you can do XML match, for example, and you can apply pattern matching on it as well. For example, I would like to extract greet, and then I want to get the message out of it. And in this case, I'm going to say, tell me what the message is, and I can print the message as an extraction and ask it to give me the content of the message as well in this particular case. So you can see that it gives us a fairly interesting way to extract the content. And I'm merely scratching the surface here. You can also ask for a pattern matching with the XPath query. And of course, in XPath, we use a / or double forward slashes. Because those are comments in Scala, use a backward slash or a backward double slash to get the XPath query itself. But let's say for a minute, you really want to create an XML content out of your data that you have in memory. How many of you have created code that spits out XML? A lot of us. How many of you want to go back and do more of that tonight? No, right? Because having done it once, you know that producing code that spits XML should be given to people in the prison, right? Nobody in the real free world should do that, right? Well, it's not that bad, actually. Let's take a look at that in Scala. So let's say for a minute that I want to have a little map here that I want to use. So this map here contains a couple of stock symbols and their share values, right? So how would I create an XML out of this? So let's give it a try real quick. So I'm going to say over here XML equals, and I'm going to just start with a little string to begin with. So I'm going to say here, let's call it as stocks. So this stocks basically is simply a XML document, and no need to put it in a double quote. Habits die hard. You saw me do that. But it's just an XML content, right? So I'm going to print this XML out right here, but I'm going to build this into a content that is going to have the data. So what do I want to put inside of this? The beauty is you can put a little Scala code right here. So I'm putting a string here, and you can see that it came out here as a string. So this little XML fragment contains a little Scala code fragment, if you will. So what I can do at this point is, rather than putting this here, I could say create elements. Let's call a function called create elements. What does the function called create elements do? Again, let's take baby steps on it. Create elements is just a function, and all that I'm going to do in this function is just return that variable, that the value. You can see that part is working. But instead of that, I'm going to say stocks dot, and I'm going to go ahead and ask him to create a set of data, right? In this case, I'm calling a map method on it. What does the map method take? It takes an element as a parameter from us, and I'm going to simply return from this, again, just little text over here, and just to kind of see how this is manifesting itself and working, right? So this is just looping through the content. It said stuff because I had two elements in my map. Well, but I really want to get the real content out, isn't it? So rather than putting stuff over here, I'm going to create an XML content, and I'm going to say symbol over here, right there. And you would notice that in this case, it's got two symbols, the first symbol ending the symbol, and the second symbol. Well, of course, I need a value in here, so I'm going to say ticker equals, and this is going to be the ticker. But what is the ticker? So I'm going to say this is going to be a ticker and a price, or a value. Let's call it as amount. And this is going to be simply equal to element. Now we have extracted the ticker value out of it, and you can see how it prints the ticker out. And now, of course, I can introduce the value if I'm interested in, and I can simply say amount over here, and that could be the ticker's amount and value. You can see that it's case symbol ticker apple 655 is the value, and then the other element is hidden right behind the scenes. So what am I really doing here? All that I'm doing is simply embedding the XML content, but I can also have Scala code to fill in the details along the way. So this becomes extremely simple to produce XML content. You're not sitting there and working through creating strings of strings of strings and suffering through it like we do in Java. It becomes a lot more simpler to work with the data, and then you can intermix this content fairly easily. So all that said, I'm going to show you two more features that I find it to be very, very cool. One of them is the traits. Now, how many of you have ever used something like a multiple inheritance in C++? Have you done that? Some of us. How many of you like to do more of that tonight? Not. Again, these are kind of patterns of suffering we've gone through, right? Because multiple inheritance is like a gorilla. It is cute when you see it in the zoo, but don't bring it home, right? It really causes a havoc on projects. We don't want that on our projects, right? But to be fair, it's not the problem with multiple inheritance. The problem really is in how C++ implemented it. Now, what are the two problems we have? The first problem is method collision, right? You inherit from two classes, they have the same method name, and they end up colliding. How do you deal with it? What if the methods tell you that they won't collide, but they would cooperate with each other? That would be awesome, isn't it? So what are traits? First of all, Scala doesn't have interfaces. Traits are interfaces in Scala. So if you only write a trait and no implementation in it, it pops out on the other side as just an interface. But if you put implementation in place, it becomes a pair of interface and implementation. Now, what is going on in this case? So if you think about how would you design this in Java, let's think about this for a minute, right? Let's take an example, and then we'll contemplate how we would design this in Java. So let's say I have a class called human, and my human contains a listen method. And the listen method simply says print, and I'm going to say I'm listening, right? So it just says I'm listening, and maybe I'll put a name here so we know who is listening. So plus name, and then I will simply say plus listening. So right there I say I am name and listening. So I want to call this. So I'm going to say val, let's say Sam equals new human. We'll say Sam is the name of this person. So I will simply say val name is a string. There we go. So we created an object, and I'm going to say sam.listen, and I'm going to call that method over here. So it says I'm Sam listening. Great. Now, what does the method listen have to do with the human? That doesn't make any sense, is it, right? So, but why did I put a listen in there? Well, okay, humans kind of listen. Who listens, by the way? He listens. There was one guy in one of my presentations. He was kind of eager. He said, "The wife?" And we all laughed at him, really. And then he kind of woke up a few minutes ago, like, "Oh, sorry," right? I mean, the spouse have a selective hearing, right? The other day, this is kind of sad, but my wife was talking to me, and I was kept nodding and coding. And then finally, she asked me a question. That's when she found out I'm not listening. And then she said, "You're not going to answer me, so I'll send you an email." And she sends me an email, so I would respond. This is really troubling, right? But anyway, we don't listen, right? Some people listen, sure. But so who listens to you? A friend listens to you. Would you agree? That's what a friend's job is, to listen to you. You go from work and say, "You know what? This job sucks." And what does your friend do? Your friend says, "Tell me about it. How does your job suck?" Or you say, "No, it's not my job that sucks, it's my boss that sucks." And your friend says, "Tell me about your boss." Not so good friend says, "Maybe you suck, not your boss," right? That's how you know who your friends are. So a friend listens. So how would you do this in Java? You would create, you say, "Well, I want a friend, but there's another friend, very important friend, who always listens to you, but never talks back to you." Who's that? Dogs, absolutely. Now we have to introduce a dog. The listen isn't the human. Hey, bright idea. Inherit a dog from human. No, dogs don't like it. Any other suggestions? How would you solve this in Java? A friendable interface, right? Then you create a human and you create a dog. You say the method is common, but I cannot put it in the interface. What would you do? Create an abstract base class. And then you would bring that method over there, and 30 lines of code later, you're like, that was a lot of effort. Well, if that is a good pattern to use, why can't the language do that for you? That's the beauty, right? That's exactly what Scala does. Let's take a look at an example how it does that. So I'm going to write the human class, leave it alone here for a minute, and then I'm going to say trait called friend, and the trait friend has a listen method. And I'm going to define a name which is a string which is unbounded at this time, right? So I've just got a trait and I've just listed that right here. Then what I'm going to do here is to create a human class, and to the human class I'm going to simply say this human extends from friend. And notice now I can run this code, it says I'm listening. But the beauty is I can create a class called, let's create an animal first, and my animal has a name also, string. Then I create a class called dog, and notice the dog overrides the name, so I'm going to say string, but it extends from animal, right? So animal. And now I'm going to say val buddy equals new dog, and I'm going to create a dog called buddy, and I'm going to say buddy dot listen, which doesn't work obviously because we haven't finished this code yet. So how do I make this code work? So I'm going to say, okay, dog is going to be entertaining this particular idea. Well, okay, sorry. I need to say this is going to be a val extends, well, I haven't gotten there yet. I'm extending from animal at this point, so I need to tell him this is the name I want to pass to him, right? So that's the method I want to pass to him. Well, there. So what do? I say with friend, and I tell him that this is going to run with friend. Now, one thing I really wish we could do in Scala was that rather than using extends here, I would have liked to use with. That way it's consistent to say I'm bringing in a trait, right? So, but anyway, I have said that this is a with over here, and that pulls it in right here and says I'm going to use that. But notice how we are able to simply use it. If you compile this down to the bytecode and take a look at it, what Scala does is exactly what you would have done in Java code with all the efforts you put in. It creates an interface for the friend. It creates an abstract base class with that implementation and nicely mixes it in. That's the word right there. It's a traits or a compile time mix-in. Let's go a step further with this. Let's try one more thing if you will allow me. So let's go ahead and say I have a class called cat. How nice is that? Now I create a class called cat. Alf equals new cat. You know where this is going, right? And alf.listen. Will that work? Right? So class cat simply extends from animal. That doesn't work. Why? Because cats are not friends, right? In fact, you go home and a cat kind of looks at you and says, why don't you go back to work? Right? It doesn't want you there, right? Anybody with a cat here? You do? What do you think? Your cat is friendly to you?
No.
No. Anybody else? What about you? Sometimes? No. Anybody with a friendly cat here? Yours?
No.
It hates you. Yeah, that's what cats do, right? So, but you know, I have a cat, and I would like to feel that it's a friendly cat. So we'll call it Venkat. All right? No, not that cat. Okay. So Venkat's cat, right? Equals new. Well, okay, Alf is a lost cause. Don't mess with it. But what about Venkat's cat? Oh, let's try cat, and we'll say Venkat's cat. And let's say Venkat's cat dot listen. No, I tried. Sorry. That doesn't work either. But what you can do is not only can you inject traits into classes, you can inject traits into specific instances as well. So what you're doing here is you're saying, I have this instance, all cats are evil, but my cat is special, right? It is one of its kind, literally. It's one of its kind. Meaning, Scala creates an inner class from the cat which implements the friend. And so it's really one of its kind, very different altered DNA sequence, and it has a listen method that it can support. So not only can you have this at a class level, you can have it at the instance level also. Make sense? How would we put this to use? This is my final example I want to show you. Say we have a class, an abstract class for a minute, right, called writer. And imagine there are several types of writers. So it's got a write method, takes a message over here, message, which is a string. And all that this message is going to do, it's an abstract class. I can have different types of writers: string writer, file writer, socket writer, log file writer, encrypted writer, thousands of them, who cares, right? But let's create one here called the string writer. And the string writer simply extends from the writer. And it's got a method called write. And that's going to take a message. And all that I'm going to do here is simply say target.append the message. What in the world is that target? Target equals new string builder, right? So I'm creating a string builder. And I'm going to also write one more method here, define override toString. And this method simply says target.toString, right? It's going to just give us the string's content. Let's go try this real quick. So I'm going to write a method called writeStuff, which takes a writer as a parameter. And the writer basically takes, right there is the writer. And all that this method is going to do is simply say writer.write. And I'm going to write something very important. This is stupid. And then I'm going to just print out the writer, right? So writer. Let's make sure this is working first. So override, there we go, fix that. So let's make sure this is working. So writeStuff, and I'm going to send a new string writer. So run that through and make sure that's working, right? So what did I do so far? I got an abstract class called writer. I've got a string writer on my hand, which extends the writer, prints something to the string builder, and now I'm just calling it, right? Nothing really great. Now, my requirement changes. They want me to not only print the string, but they want me to print the string in uppercase. Where do I put the function called print in uppercase? Let's look at some design options. One idea, I can put that into the writer abstract class. What do you think? No. That's going to pollute that interface, right, the abstract class. And you come from vacation and you've got 20 methods hanging in there. It's like, what happened, right? So no, you don't want to do that. I can put that in the string writer. What do you think? No, not a good idea. Because there are 20 other types of writers, right? And we got to stick in each one of them. And that's not going to be pleasing the dry principle, right? We'll be duplicating the code. So here's an idea. Why don't we use a trait? So trait, and the trait is going to be uppercase filter, which extends from writer. So what does that mean? It says I can mix this trait into any class that has a writer implementation. And I'm going to define over here a write method. And this takes a message as a parameter. And what does it do? It says I am going to take the message and do to uppercase on it, right? So it converts that to uppercase. But that's not the destination. So in other words, what Scala does is, when you have multiple traits being mixed in, rather than them colliding at each other, it forms a nice train of these traits. So they all kind of connect to one another, and when you invoke a method, it nicely flows through from the right to the left as the call goes through. So rather than the objects colliding, they form in a line and cooperate, nicely decorating this particular thing, so it becomes nice decorator pattern to use. So let's see how that's going to work in a minute. So where do I put this result from? So I say super.write and ask him to put it to the object to the left. The word super here doesn't mean super. It means send this to the object in the chain to my left as you traverse through it, right? And of course, for this to work, there are two contracts we have to establish. One contract is, this is not an arbitrary method. This is a method that actually comes from this writer. The other contract is, the destination object should have it also. So to emphasize that, we have a deadly combination of words called abstract override. The only way to deal with it is not to look at it again, okay? So just put those two words in there, and that simply says you want to kind of say, emphasize those two requirements you want to draw. How would this really help? Notice what I can do now. I wanted to just print this string out, that's all I wanted to do. Let's fix this error first of all, line 21. So super.write, and I'm taking the message and printing it out. So this is going to be abstract override. Oh, pardon me. So this should be right here. This one here. There we go. So now you know the reason for having that, right? Excellent. So right there we wrote that. Thanks for the help. So write stuff, new string writer with uppercase filter, and you see how that's working. So far so good? You say, all right, but what if I have another kind of this filter? Well, let me give you an example of that. It turns out this was a hard day in my life when I learned that I'm the bad guy in my house. I mean, I travel a lot. I hang out with guys like you. What do you expect, right? And I went home one day, and I said something, and my little boy runs to my wife and says, Mommy, Daddy is saying bad words. And my wife had to come and discipline me. She came to me and said, did you use a bad word? I said, of course not. What kind of bad word would I say? She leans over and said, did you use a S word? And I said, you mean that word? She's like, not that word. Did you say stupid? I said, of course I said stupid. What's wrong with that? And she said, I'm teaching my children not to use words like that, to be polite and well-mannered. And you come back from your trips and teach them all the bad stuff. You know how difficult that was? I had to put my head down and say, I'm sorry, ma'am. I will not say that word anymore. So from now on, I have to filter what I say at my home. I cannot use the word stupid. Does it happen to you also in your houses? Yeah, that's kind of hard, isn't it? So we'll fix it. So I'm going to say trait, profanity filter, right? So profanity filter extends from writer. And what does this do? Here is the abstract override define write message, which takes a string. And in this case, all that I'm going to do is super.write. And what do I say? Message.replace the word stupid with the word. All right? So let's try that. So write stuff, new string writer with profanity filter. There we go. So run that through. That seems to work. You know where I'm going with this, right? So write stuff, new string writer with uppercase filter with profanity filter. Isn't that awesome? So we mix them together, and you can see that it printed that in uppercase. I'll move this up here. It printed that in uppercase, and it removed the word at the offending word. You say, wait a second, but how does this really go through? Well, it goes through from the right to left. So it forms a chain of these objects. So when you call this, you are first sending it to the profanity filter, which removes the offending word, sends it to the uppercase filter, which converts to uppercase, which then sends it to the string writer, which puts it into the target. Make sense? You say, aha, but we found an issue with the code. If I put the profanity filter first and the uppercase filter next, what's going to happen? It is not going to remove this, right? But no worries, this is perfectly fine. Because the other day I was very upset and I screamed, "This is stupid!" And immediately my son's eyes wide up and he goes to my wife and she says, "Daddy's upset right now, so be quiet." So this is perfectly fine, right? So this fits the domain really well. So as you can see here, we looked at quite a number of interesting features that Scala provides. And when you go examine Scala, you will notice that Scala does a lot of things really nicely. And when you look at those things, it's to a certain extent things done right. And in fact, I would argue, if anybody programs in Java, I would not let them program in Java if they have not read effective Java, right? And then as you're reading through effective Java, you kind of wonder, if this is the effective way to write Java, why can't they fix Java to do it? So I got some secret news for you. They actually fixed Java, but when they got it done, they called it Scala. That's all I have. Thank you.